NeuroCheck offers extensive hardware management capabilities. It provides field-proven drivers for various kinds of imaging sensors, also supporting GenyCam Gen TL compliant cameras. In addition, you can integrate your own device via the Open Hardware Programming Interface. All devices required for the inspection system are managed via NeuroCheck's Device Manager. The Device Manager can be opened here or via the menu, System, then Device Manager. These are the categories under which the configured devices are listed. So far, no devices have been added. Click here to add a new device. We have to select a category depending on the device we want to add. Let's add a digital camera. Here we can select the NeuroCheck device driver. Each driver allows NeuroCheck to communicate with a particular subset of devices. We have a NCCG camera model connected to this computer, so we select the NeuroCheck Gig E driver. In the About dialog, we can check whether the driver is installed correctly. The green ticks show that this driver is working properly. The camera is already set up and ready to be added in NeuroCheck. There is a comprehensive guide to setting up NCCG cameras. It is located in your NeuroCheck installation directory. Open the folders, Documentation, and White Papers. Then open the PDF checklist for using NCCG cameras. Let's go back to the driver dialog. The Diagnostics tab shows logs that can help with troubleshooting. Make sure that logging is enabled if you need it temporarily. In the next step, devices are searched for that are compatible with the selected driver. If your device is not listed, check if your operating system recognizes the device correctly and if the necessary drivers are installed. You can also contact our technical support. Great! Let's add the selected camera by pressing Finish. Using the camera as an example, we will now look at the other functions of the Device Manager. Here you can find device-specific information. The settings in black can be edited directly. Some of the grayed out settings can be edited in the Properties dialog. The available setting options may vary depending on the driver and device. The Properties dialog shows us a live image of the camera and the camera settings. As we can see, the live image is quite dark. The histogram can be used to determine the optimal exposure value. It is also an indicator for the white balance. Because the color channels are overlapping each other, the white balance is fine. Let's brighten up the image. Instead of changing the exposure time, we can also increase the gain for a brighter image. If you need tips about the other settings, you can select the setting and then click Help. We close the Properties dialog with OK to keep our changes. The Test button can be used to check whether your device is working properly. The extent of the test depends on the driver. The NeuroCheck Gig E driver offers an extensive test of properties, functions, and execution times. Let's save our current camera setup via Export. The setups are typically saved in the Camera Settings folder of your project. Now let's reset the device settings to their default values by clicking the Reset button. As we can see from the live image, the camera settings are reset. To get our setup back, we click Import and load our saved setup. Let's check the properties. All right, there is our setup with increased gain setting. Make sure to save your camera setups so you won't lose your settings. Next, let's take a look at virtual devices. You won't always have all the required devices available while developing an application. Therefore, it is possible to add virtual devices that serve as placeholders. The steps for adding a virtual device are the same as for real devices. Click New to add a camera. Choose the virtual camera driver and add an available device. In the Properties dialog, we can assign image files to the camera. These simulate the live image of a real camera. Hold the Shift or Control key while selecting to select a range of images. Let's rename the camera to Virtual Camera Color in the device details. Then we add a second virtual camera. Let's assign grayscale images to this camera. We name the camera Virtual Camera Mono. Now we leave the Device Manager with OK to keep all changes and added devices. The live images of our cameras can be accessed via this button or via Tools, Live Image in the menu. It's possible to rearrange the live image windows by clicking the Cascade option in the Arrange menu. Excellent. Now I'll give you an insight into how you can let your application communicate with the devices. If you currently have a check routine open, click New to add an empty check routine. Then we add the Capture Image and Transfer Image functions. Capture Image commands a sensory device to capture an image, and Transfer Image loads the image into our application. We open the parameter dialog for Capture Image to select one of our added cameras. We can see all the cameras we added in the Device Manager. Let's select Virtual Camera Color. Then we select the same camera for the Transfer Image function. When we execute this function, we capture an image and the image is transferred and displayed. In addition to image acquisition, other commands can be executed on the target device. To do this, we have to add another function. This function is under the category Tools, and it's called Control Device. We add this function before Capture Image to adjust the camera settings before image acquisition. So we select Capture Image, and then click the Insert Function button. The Control Device function allows to set and to read device properties and to execute methods. In the parameter settings, we select the device Virtual Camera Color. Then we set the mode to Set Property and choose an adjustable property. We select Gain and enter the value 3. When the function is executed, the new property value for the device is set. If we then execute Transfer Image again, the resulting image is now significantly brighter. Let's go back to the Device Manager. Now that we've multiple cameras and a check routine, I can demonstrate the functionality of the arrow buttons. The arrows can be used to change the device order in the tree view. Let's move Virtual Camera Mono up by one position to switch places with Virtual Camera Color. It's important to note that the device order affects the application. I'll show you what I mean in a second. Let's execute Transfer Image again. We can see that it displays a grayscale image from our Virtual Camera Mono instead of the color image. By changing the device order, the selected device of our functions changed too, because the selection refers to the index in the device tree instead of the device itself. This means you can use the arrow buttons to comfortably switch your devices via Device Manager without having to reconfigure your applications. In addition to the virtual camera, virtual digital I/O boards or virtual field buses can be added to simulate the process integration. To do this, we select the virtual I/O driver and an available device. This is the virtual I/O board, with green lights for the input bits and red lights for the output bits. With I/O devices, we can use this button to test the communication. Here we can activate output bits and test whether the signal arrives at our device as expected. We can also check whether inputs from the device arrive. You can learn more about process integration in another tutorial. Lastly, for those who are interested in using NeuroCheck's open hardware programming interface, there is a detailed guide that shows you how to implement your own driver for NeuroCheck. You can find the instructions in your NeuroCheck installation directory. There, go to the Documentation folder, Programming Interfaces, Hardware, and open the NeuroCheck 6.2 Hardware Interface PDF. That's it for this tutorial. Feel free to connect your own devices with NeuroCheck Evaluation License. See you in the next video.